In this example of the Galilean transformation, we have what you'll see is going to be a very simple mathematical calculation to make at the end to get the answer, but it's a little bit tricky conceptually in terms of reading, interpreting the language in the question to properly structure our Galilean transform, our vector v equals v prime plus u, and that's really nothing more again than a vector addition where we can say it's a normal, vector c equals vector a plus vector b. We've been doing that since our chapter 3 vectors chapter. So let's see the language in this problem. We have two automobiles approaching a corner at right angles to each other with the same speed. So identical speeds of 40 kilometers per hour, 11.1 meters per second. And we're asked what is the relative velocity of one with respect to the other. Now, we're given some further clarification here, which you may or may not be given in other questions. So here we are told, that is, determine the velocity of car 1. So the velocity of car 1 as seen by car 2. Now that language, as seen by, is very important. So as seen by tells you that that will be the, and I have it in quotes here, the at-rest observer. And yeah, clearly here we have an issue we'll get to in a moment, that even though car 2 is actually moving. So the equivalent, conceptually, of car 2 actually moving to the corner would be to allow the corner and the whole world to stream backwards against car 2 at exactly that 11.1 meters per second. And as you can see, that's exactly what we do, and we call that our u vector. Now, the other language you can see in a problem, as seen by, and you may also see or with respect to, as it is here. So with respect to. So 1 with respect to 2. Or you may see 1 relative to car 2. So any of that language tells you that it's car 2 that is going to see the blue vector and is going to be our at-rest observer. But this trick of letting the ground stream backwards is important for you to know, because if both are in motion, that's what you have to do. One of them has to be the, in quotes, at-rest person, and then the ground streams backwards. Well, the rest of the problem now falls into place relatively clearly. Car 2 will see car 1. Car 1 becomes the object moving in the moving medium, which it moves at 11.1 downward, whether the ground is moving or not. That's what the engine of car 2 does with respect to the moving medium, regardless of whether the moving medium is moving or not. We now have our vector addition in place. We've correctly identified our v vector, our v prime vector, and our u vector. We set up our tip-to-tail vector addition as I've shown here. So we have v prime tip-to-tail, v prime plus u equals the vector v. So we get our right triangle, equilateral, so I didn't show it, but we can certainly put that in. It would be 45 degrees, so car 2 is going to see car 1 coming at this blue 45 degree, and you use the Pythagorean theorem, of course, to get the value for the blue v vector. So there we have it. Again, this is definitely a little bit tricky in terms of the language of the question, so please make sure that you understand what was said, rewatch if you need to, and certainly ask questions if you need to. So hopefully this example has helped further clarify applications of Galilean transformation, and as always, we can now move on.